Welcome everyone to yet another exciting episode of Path to Code. We've been touching on quite a few concepts over the last few sessions, and today is going to be an exciting one again. Today we're going to be talking about how we can really write unit tests in Apex, right? Um, so a quick introduction about me. My name is Jigar Shah. I'm an enterprise solutions architect, and you guys can follow me on Twitter and LinkedIn. Jigar Shah189, that's my Twitter as well as LinkedIn handle. So what are we going to talk about today? So today we're going to talk about most primarily the need for writing or having unit tests within your Apex test code, right? The next we're going to be talking about is what is test code coverage. You must have heard this term, being thrown at you quite a few times, and it is something which is very important, and it's a concept that everyone should understand who is working on the Salesforce platform. Next, we're going to look at what the blueprint of a test class is, what exactly a unit test looks like, how what are the components that go inside a unit test, and last but not the least, we will also learn about how to go out and execute unit tests, see some crucial or some significant concepts that are really important to know when you are writing unit tests. And of course, no session is done without best practices. So we're going to be talking about best practices of unit testing on the Salesforce platform. And of course, question and answers. So that's what we got for today. Before I start my session, was just some housekeeping rules for everyone on joining the conference today. Please ensure that you mute your mic. Do not shy away from asking questions. If you feel that you don't want to unmute your mic and ask questions, you might as well post them in the Q&A window, the chat window. No, please understand that no questions are silly. By asking questions, those questions are only going to help you learn and understand the topic better. And last, if we're not able to answer the questions as I progress to the session, we will try to cover all the questions in the last 15 minutes. And even if you're not able to do that, please go to our blog and post the questions there, and we'll make sure that we answer all your queries, right? So with that, let's just understand why we all keep talking about unit tests in Apex. But I think one of the primary things that we need to understand as people working on the platform is, why do we need to write Apex unit tests? What is it that Apex unit test gives us, making it such an important tool of the platform? So, and I talk to a lot of people in the Salesforce community. I interview a lot of people, and one of the most important things when I ask them is, why do we need to write Apex unit tests? The most common answer that I get is because Salesforce mandates it. It's great that Salesforce mandates it, but we also need to understand what are the benefits that we get out of writing Apex unit tests, right? So primarily, testing is done to validate the desired behavior. So any piece of code that you write, whether it is on the Salesforce platform or whether it is using any other technology, that piece of code needs to be tested or verified to ensure it is doing what it is supposed to do. And that is one of the primary reasons why testing is done. But with the writing unit tests in Apex on Salesforce, we've gone a step further because that reduces a lot of overhead. Okay, most of the time what happens is when testing is done, it's manual, right? So as such, there are people who are sitting in front of a terminal and are trying to, maybe you have a form and you're trying to fill in the form and you're trying to test if all the data went through, if there are any inputs that are restricted, things like that. But the UI testing has its limitations, right? So with unit tests, you can do a lot more beyond the regular testing that you do, right? Of course, because these are written, these are scripts that are written, they are reliable and consistent. So every time you run the script, you will get the same results in a consistent manner, provided nothing has changed. Okay. Um, the other important thing to understand is whenever you're building any piece of software or writing any piece of um, any program, it is better to fix any bugs that come in earlier in the development cycle versus when you move ahead. As you move ahead in the development cycle, the effort required to fix a bug it increases, right? So when the effort increases, automatically it is an expensive affair, right? So one of the other things that Apex unit tests helps us achieve is it helps us reduce the bug fix cost, right? um, the another important piece that we have from an Apex unit test standpoint is we often write or build applications that are meant for bulk operations, right? Gone are the days when there are single records being manipulated. Today, everybody needs things faster, quicker, more reliable. So if you really want to test the application or code, and if it, to see if that is capable of handling bulk. When I really talk about bulk, what I'm really referring to is multiple records, right? So if I want to test how my program is performing, or how my piece of code that I've written is performing via on the Salesforce platform, Apex unit tests help me really test that feature, and I am exactly able to tell how my program or application is going to be performing in real time when it is bombarded with bulk records. Last but not the least, uh, this is a little known aspect, but a very important aspect of writing unit tests is it helps you introduce changes effectively. I'm going to have a demo um, in the upcoming slides where we will try to see how we can use unit tests as an effective change management tool. So these are some of the key reasons why we should be writing unit tests. Okay. Now, um, the next we're going to be talking about is test code coverage. So what's test code coverage? So any piece of Apex code that you write on the Salesforce platform, Salesforce mandates that it needs to be tested. So you need to write your code, plus you need to write your Apex scripts that will test that code. Now, test code coverage is a term that is coined, and it really means it's basically a percentage, right, which determines the percentage of the code that is tested. So let's say if you have 100 lines of code written on your in Apex on the Salesforce platform for your org, Salesforce mandates that at least 75 of these lines need to be tested, right? And the number keeps on varying depending upon the number of lines of code you have, right? So higher the lines of code, or higher is the customization bit on your Salesforce org, um, higher is the test code coverage required. You need to make sure that you keep up with the 75% mark, right? And that's where you end up making sure that you write test code for all the Apex code that you have written. um, Now, one is we understand what is test code coverage. Second is we also understand what do you end up testing, or what should we be testing when we are writing unit tests. Okay. So there are peculiar things or very specific things that we should be testing as a part of our Apex unit tests. Okay, so one is of course the single action, which is the regular which basically refers to manipulation of a single record, or if you've got a form, um, whatever that form is supposed to be doing, that's what you test. But beyond that, there are some key aspects that which we will talk about. So first and foremost, bulk actions. Okay, we talked about that. So what are bulk actions, or what is bulk testing? When you have records, more than 200 records for an object, okay, and you're testing with more than 200 records at a point as an input, then that is bulk testing. Okay, mind you, this is the most common piece of testing, but uh, it is most commonly ignored. Like, a lot of people don't really end up bulk testing their applications. As a result, most of these applications, when they go to production and go live, they fail, right? So this is an important aspect, a crucial aspect, and we need to make sure that this is kind of taken care. The next is, we ideally, as a part of the Apex unit tests, you should be testing the positive behavior. And by referring to positive behavior, we're really referring the actual expected behavior. So for example, if you had a program which would add up two numbers, or let's say divide two numbers, um, the the resultant of that division is the expected behavior, right? So if you give two numbers as the input to a particular method, the expected outcome is it will divide and give you the number, uh, right? So that's the positive behavior. But you also need to test the negative behavior. And when we say negative behavior, we're typically referring to unexpected behavior. So in the Salesforce world, these are commonly referred to as the positive test cases and the negative test cases. Okay, so an example of negative behavior extending on the earlier example of division would be that I give two numbers where the number that is dividing the other number is a zero, right? Where you're really getting a divide by zero exception. Now this is a boundary condition. This is unexpected behavior, right? Ideally, somebody should be giving the right whole numbers and the division should happen. But what happens if somebody gives a negative number, or what happens if somebody gives in a zero, right? So you will encounter unexpected behavior. So one of the key things to ensure while writing your unit test is to make sure that you account for such negative behaviors also, right? And another important aspect, we have a very robust security model as a part of the Salesforce platform. But often the verification of which user has access to what kind of data or what kind of features is not tested. So with Apex unit tests, you get the flexibility to do that. You can exactly say, if I have a user X versus user Y, user X has access to features 2, 3, and 4 versus user Y has access to features 4, 5, and 6, right? And we can make sure that they can only run the code associated with those features only. So you can exactly do that, and we're going to see in a bit as to how that can be done, and while you actually go and write out the unit tests. So before we jump into all the fancy features of how you can write an Apex test class, let's really understand what exactly a test class comprises of. So what I have here on my screen is a typical test class that most of us would end up writing, all right, on the Salesforce platform. A test class is just another Apex class, but it has certain special behavior that makes it uh, so special, right? So one of the first things to understand that all test classes are marked with an annotation, right? @eastest. So that is the annotation that every test class is marked with. Okay. The reason why it is marked with this particular annotation is because this annotation helps the force.com engine, the compiler, understand that this particular class is a test class. Now, why do we want to really help the compiler understand that this particular class is a test class? Because the total, I mean, there is a governor limit set by Salesforce on the total number of lines of Apex code, or total Apex code that you can have within an org, right? So when you demarcate something with @istest, right, that automatically becomes a test class, which tells the compiler that, hey, this is a test class and we do not need to account for the code written within this particular class against my overall code limit, the governor limit that is set for the code on my org. Okay, so test classes are excluded and do not count against the governor limit. So that's the primary reason. Second, in a couple of earlier sessions, I believe Jitendra talked about the different access specifiers we have. So by default in Apex, whenever you write a class or a piece of code, the access specifier, the default access specifier is private. Okay, so you can either demarcate your test class as a private class or a public class. Test classes really run on their own. You don't really need to have a piece of code invoke or instantiate a particular test class, right? And we'll see how you can run the test classes from the Salesforce interface. But that's the reason why you don't really have even having a private test class is okay by default. Everything is private, so if you don't really put an access specifier, it's private anyways. um, Episode 5 test, that is the name of the class. It could be anything in your case. One of the recommendations, especially when you guys are, a lot of you are trying to understand test classes, is the way you name your test class is also very important. All right. If you have a class which says my or an HTML parser, right? So you obviously have the flexibility to name your test class in the way you want. You could give it a completely different name. Having a test keyword in the name of the test class is not a mandate. Okay, but the reason, the practice that I follow at least is, let's say if you have a class called as an HTML parser, the way we really put the name is, we call it HTML parser test. The reason why we do that is, whenever you see these classes in any kind of editor, or an integrated developer environment, the actual class which containing the business logic and the test class appear, or are showcased right below each other. So you don't really, one is, it is very intuitive, and second, it's very easy to spot. So this is primarily the reason why you should make sure that you are naming your classes, and especially test classes, appropriately. Now, every test class comprises of unit tests. A unit test is a specific piece of code. Here it will be a method which focuses on testing a certain aspect of the entire application. Okay, so I'm not sure if a lot of you are familiar with this term called as use case. A use case is one specific feature or flow within the complete application. So you could have uh, a large application maybe with 100 different use cases, or you're building just a small application with, let's say, 5 different use cases, right? But your unit test methods, which you see over here, which I've right now written as my unit test 1, should focus on testing each of those use cases. Okay, so how do you write a unit test method? It's a static. You use the static keyword. For people who don't really know what static is, you can refer the session by Jitendra, the last session, where he explained everything about object-oriented programming. Then the next keyword that we're using over here is the test method keyword. The test method keyword is the keyword which the Salesforce platform recommended. The keyword tells the platform that, hey, this is a unit test method and it is different from a regular method. Okay, void is because there is nothing to return. So one of the key things to note over here is when you write unit test methods, they do not accept any parameters, neither do they um, return anything. Okay, so it's one very important thing that we need to understand over here. All right. um, so it's very important how you structure your unit test methods. Unit test methods should be focused towards a particular use case. Okay. uh, that earlier, I think a couple of releases ago, before actually lightning came through, um, it was the Salesforce platform permitted writing test methods, okay, within a regular class. So let's say when I say a regular class, a normal Apex class, which has some actual business logic and is trying to perform something, you could write the unit test method that you see over here, you could include that within the regular test class. But I think after API version 28.0, Salesforce has stopped permitting that. So what they now recommend, or they basically now enforce, is every developer is supposed to write a separate unit test class. You cannot include unit test methods, okay, within a regular Apex class, which contains business logic, right? And what they also did was Salesforce deprecated the test method keyword. Okay, so it's the idea is that you can use @eastest in place of test methods. So both of these keywords are equivalent and can be replaced. But what Salesforce recommends is um, use the @eastest keyword, because that is something what they recommend, and that's what needs to be followed. But even does that mean that if I'm going to write test method and are my unit tests not going to work? No, that's not the case. They will work fine. It's just that @eastest is a better thing that they recommend, and that's something that needs to be followed. So yeah, this is a very basic test class. There are quite a few things which we will keep adding, which will be required in the real world to understand how to write test classes which are more comprehensive and test real world scenarios. Okay, so I think that brings us to our first demo. So let's just go over to the Salesforce org, right, and log in and see what we have. So let me just walk you through of what I have here. Uh, this is a regular Apex class that I have written. It's performing certain processing and certain operations, right? And this is the class that we are going to be using to showcase and understand different concepts of uh, writing unit tests. Okay. Um, so so we just looked at a blueprint, right? And it looked something which is very similar. Okay. If you really look at the code.
Hey Jigar, we can't see your screen, the class.
All right. I'll just give me a second. I'll make sure I'll share it. All right. Hopefully you guys should be able to see the screen now.
Yes, thank you.
All right. Thank you for letting me know. So I'll just make sure that, I'll just repeat the piece again. So this is the particular class, EP5 number verification service. That is the class, which is the regular Apex class. That is my actual business logic, which needs to be tested via the test scripts, right? So this is going to be our actual source code, which we will test and try to see different features and functionalities associated with writing unit tests on Apex. But before that, let's just look at our very first piece of unit test code. If you really see, it is not very different from the one that we saw on the slide a couple of seconds ago. Only thing what I've done is, so most of it is, it has an @is test, it has a private access specifier. And what I'm trying to showcase over here is, your test classes or unit test methods will execute in an equivalent fashion, irrespective of whether you're tagging it with an @is test annotation at the method level or using the test method keyword. Okay, so this is the piece of unit test that I have written. Okay, if you see, there's nothing very different that we are doing. We are writing a class, we are writing a method, only that there are specific keywords which we are using to make sure we are writing comprehensive and the right kind of unit tests. Okay, so so we have written the class. One of the key things is to understand how we run it. Okay, so one of the easiest things to do is to use this button right now, where I am logged in into my Salesforce instance, and this is the developer console that is opened. For people who don't really know or are not conversant with what a developer console is. So developer console is an integrated developer environment which is available right within your Salesforce instance. So the moment you log into your Salesforce instance from the browser, and if you have access to the setup panel, when you click the gear icon on the setup panel, there is an option to open up the developer console, and clicking that will bring up this window which I have over here. Okay, and you can do a lot of different things. This is a tool which is required, or which most of the developers will use, right? Who play around with. You can write a lot of different types of code snippets. You could write Apex, you can write Visual Force, you can even write Lightning components through the developer console, right? So coming back, how do I run this Apex class now? So the easiest way for me to run this particular Apex class is to use the run test button. Now, one thing to note over here is, because this is a unit test class, we have the run test button. But if you see, if I just switch over the tab and I see the regular class, the Apex class, the run test button is not available. So the platform is intelligent enough to understand that this is an Apex unit test, and that's the reason why the run test button is given over here. So what I'm going to do now is I'm going to hit the run test button and see how my unit tests are performing. Okay, now one is executing the unit tests, but the other thing is, where do I get to know that whether my test class has run, whether everything that I'm supposed to be testing has been tested appropriately. So you have a test console over here. Okay, so it's actually a collapsible window, and it's the next sorry for that, it's the next tab right next to your debug logs, the logs panel within your developer console. So this is the place where you will actually be able to see your run tests. Okay, let's say because there are system.debug statements which are going to output something to the developer log, you will also have logs created. Okay, the test panel is typically to give you a summary of your execution. So if you had 5 test methods, in this case we only have 2 unit test methods, it's going to show that these 2 unit test methods ran, and if they whether they passed or failed. So let's just go ahead and run this particular unit test code and see if there is a difference between the test method keyword versus @is test. So if you really see now, because this was a bare bones class with very limited features, if you see, it recorded the entire test run, which said that the test run comprised of this particular class, which is EP5 demo 1. And within EP5 demo 1, there are 2 unit tests that ran. The first was the my unit test 1, and the second was my unit test 2. Now this just gives you more of a summary. Okay, it doesn't really tell you what went on behind the scenes. So what I'm going to do is switch over to my log panel. You also see that it will generate a test, a developer console. I'm sorry, a log. I'm going to open up that log here and filter the debug statements. So if you really see this, the debug statements ran irrespective of whether the class was, or whether the unit test was annotated with @eastest or with the test method keyword. Okay, so this just proves that they are seamless. You can use them interchangeably, right? Okay, one of the things to note, okay, let's say if you try manipulating certain records, okay, or when I say manipulating, you try to update certain records, certain values on a record, you insert certain records, okay, or you're deleting something, or maybe you're trying to send out emails, you're trying to test code which is sending out emails. So if you're writing unit tests for those and you're trying to perform any of these within your test code, or if any of this, so let's say if you have a class which is sending out emails and you have written a unit test which is trying to verify that class, and as a result this it invokes the email sending action, be rest assured any changes that happen because of a test class or a test method execution are not committed to the database. What does this mean? That whenever you make changes, those changes will not be persisted. So let's say you updated a value on a certain record and you tried to change it from 10 to 20. Okay. After the test code is run, the actual value, if it was 10, will remain 10. Okay, it will only make temporary changes, but it will not commit anything to your database. So neither does it send out emails, nor are you able to perform any web service callouts within your test class. Okay, so these are important things that we as developers we need to understand and keep in mind while you're writing unit tests. Okay. All right, I'm going to switch back now to my presentation, and okay, so that was a quick understanding of how your test code works. Next, let's look at what are the important things that we need to understand in order to make sure that we execute our unit tests successfully. Okay, so when you're writing when you want to execute unit tests, it is not that if you have 50 test classes you need to, it's a mandate to execute all the 50 test classes all at once. In fact, it is always recommended that you execute each of the unit test classes separately, individually, as separate units, so that they are testable and you really understand if a specific unit test class is able to test what it is actually designed to test, right? Or whichever Apex class it's really designed to test. Now what I'm going to do is, we saw how we can run tests, or run our test code from the developer console. There is one other way in which you can run your Apex test code. So I'm going to switch back to my Salesforce instance. Okay, I'm assuming everybody's able to see the Salesforce instance, and you can go to the setup panel, and within your quick find you can just type Apex, right? Now if you see, when you type this, you see two options which come up very prominently. One of them is the Apex test execution console and the Apex test history. Okay, so let me just help you understand what an Apex test execution console is. All right, so the Apex test execution console allows you to do the same thing. It allows you to run unit tests, but it also gives you the ability to select what tests you want to run. So you can actually say select tests, and so it will automatically detect which are the test classes. One of the other things to remember is um, the nomenclature. So try to give meaningful names to your test classes and your test method so that they're easy to identify when you're actually doing the execution. So if you really see, you can go to a particular test class, okay, and you can also run it from here, okay. Um, the other thing that to note is there is something called as an Apex test history. So let's say you have um, you've run your Apex test for a period of time. All the history is recorded over here in this Apex history test history console. So it tells you what was the run ID, and if you really go in and dig deep, it will tell you which were the unit tests that were run, what was the name method name, which are the ones that passed and which are the ones that failed. Because we don't really have any failures, we don't see any entries in the fail tab, but you can actually go and see all the test class history that is being run on the Salesforce platform. So usually what happens is you could have 5 different developers running Apex tests because each of them might be working on a different functionality or a different module, and they might want to run test classes which are relevant to that functionality. So you can actually pick and choose. At the same time, you can, let's say if I am working on a certain piece of functionality and I know that there are specific 4 or 5 test classes which I will always be able to run. So I can also create a test suite, okay, from this new suite option within my developer console. So a test suite is nothing but it is a grouping of the test classes that you would like to execute, okay. So um, switching back to my slide deck now. So when you're running unit tests, you can either end up running all unit tests, you can run some or methods, all methods of a specific class, you can run some or all methods of a specific set of classes using, or you can have predefined suite of classes, which is nothing but a test suite, and we talked about that a while ago. Now, uh, what are the tools that are available that or made available by the Salesforce platform which help me to run unit tests? Okay, some of these tools you've already seen, right? So the Salesforce user interface. So what we saw, the test execution console that we just saw a minute ago, um, it is this particular screen that I'm referring to, is one of the places where you could run your unit tests. The other being a force.com ID. So force.com ID, I would not really say force.com ID because now there are a ton of integrated developer environments available to write your code. Uh, so just like developer console, which is readily available ID from Salesforce within the Salesforce instance itself, force.com IDs are basically additional pieces of software which you can install on your machine, and you can do the same thing. You can write your code within these IDs and run your tests from that particular ID directly, and you will end up getting the same result no matter where you run the test code from. Okay, whether you're running it from a user interface or through the dev console. So Lightning Platform Dev Console is what we just saw, where we were using the run test button. Okay. Um, and last but not the least, but if you think you want to have a programmatic access and you want to make sure that you want to run test code through an API, so the platform allows you to do that. There is a SOAP API which is available, and it allows you to run unit tests from from maybe an external application. So maybe you could have a mobile app, and somebody hits a button, and that button on the mobile app, click of a button, will result in executing a unit test or running a unit test on the Salesforce platform. The most common use case for using an API is typically, there's a term called as continuous integration. I'm not sure if you guys are aware, So what happens is when you're really doing enterprise level development or implementations, there are multiple, there is a landscape that you have. So you have a developer box, you have, when I say a box, typically a developer org, you have an SIT, which is an integration org, where developers, multiple developers who are working on their test code, sorry, on their code, you know, they will collate all their code in that particular org. Then there is UAT, which is a user acceptance. So all these environments are actually different. Now, how do you make sure that you have a seamless flow so that once a developer checks in certain code, certain pieces of code, you know, automatically the unit tests run, verify and tell him if the code that he has built is complying with the tests, okay? And it could then be pushed over to, let's say, from from his developer or to an integration sandbox automatically. So continuous integration is the process where it helps you achieve all of this automation. Okay, so that's when APIs come in really handy, and you would want to execute your unit tests via the API. Okay, so that brings us to the next demo, and let's see what we're going to what the next demo is going to explain to us. So we talked about testing different kinds of behavior, right? We talked about testing positive and testing negative behavior. So I wanted to showcase to you, you know, what does positive and negative testing mean, and why it is very important to do negative testing. Okay. Positive testing is basically the actual expected scenario. Negative testing is something which is unexpected. Okay. Now, and this is an observation that I've made, is most times when test code is written, the test code is written to ensure that we achieve that 75% mark, which is the mandate laid down by Salesforce. So what happens is people only write their test code to make sure that at least 75%, you know, I'm getting 75% or a little higher number. But as a part of the best practice, it is always recommended that don't write test code to achieve that 75% number. Okay, make sure you write test code to unit test each and every different scenario. So so if there are like 5 scenarios, you know, make sure you write unit test to cover that. Okay, and when you do that, in turn, you will automatically achieve the 75% mark. Okay. Now this is the 75% mark is a mandate when you are deploying to your production instances. Okay. But if you're really deploying from one sandbox to another, you don't really have, you know, there's no mandate per se of having 75% of test code coverage, but it is absolutely essential that any code that you write on the Salesforce platform is always tested via the unit tests. Okay. Um, if you're writing Apex triggers, for people who are not really conversant with what an Apex trigger is, an Apex trigger is a special type of Apex code which executes when some certain type of DML operations are performed. Okay. What DML operations are basically the data manipulation operations that you can perform in any kind of database. So you have insert, which is creation of a record, update, delete, right? So triggers are something that execute when such activities occur on any of your records, provided you have a trigger on the same object. Okay, so Salesforce mandates that each of these triggers have some test code coverage. In this particular case, there's no mandate that, you know, it needs to have 75%. The 75% test code coverage is the overall test code coverage. So let's say if you have uh, 50 lines of code written in one particular class, and you have 50 lines of code written in another class, another Apex class. So the total lines of code on your Salesforce org is 100, right? So what the actual mandate is, this is again a misunderstanding which a lot of people get confused over, is the mandate is over the overall org code coverage, which means the total number of lines in your org across all the classes that exist. Okay, so it is, so just by saying that 75% of, or 75% of the class that I developed um, is tested via a unit test doesn't really guarantee that you will have a safe deployment. What you really need to check for is the overall org test code coverage. Okay. Um, all right. So we're going to look at demo number 2. Okay. And we're going to talk about how we can check for positive and negative use cases. So in this case, the positive use, so this is the class that I'm testing. It's a number verification service. What it does is it basically checks if the number given uh, is odd or even, right? So I'm using a mod function to check that, um, right? Uh, but if you see that there is a branching logic, and we're using if else statements to check this particular functionality. So in this particular case, if you see, um, let me just run this particular class and you'll understand what I'm trying to say is, if I run this particular test, okay, the tests will execute. Okay, maybe there was a failure. Let's just quickly see. Probably because I've made some changes. Let me just make sure that the save happens properly. And now I'll go and run this particular check again. Okay, so the failure happened because the changes that I just made did not save. So now everything executed fine. So if you really see, the code coverage is always shown against the class being tested. So in our case, the class being tested is EP5 number verification service. And if you really see, the code coverage for that particular class is 87%, but the overall code coverage is 11%. So the 75% mandate is on this overall test code coverage. Okay. But the essential piece that I was trying to showcase with this demo is, we, as a part of our unit test methods, we are covering 7 out of the 8 total 8 lines which are available in my particular code. Okay, one of the things to understand that if you have system.debug statements within your actual class being tested, those are ignored. So those are not really counted as valid lines of code. Okay, so let's say if you have 10 lines of code, out of which 2 are debug statements, so it actually will. So now if I go back to my demo and I now change, so what I've done is I've written 3 basic test cases, right? The first test case really tests if the output is an even number. The second checks if the output is an odd number. And last but not the least, I'm checking what is the expected behavior when a negative number is input, okay, in this case. So just to walk you guys through the code is very simple. I'm creating an instance of the class, and then I'm calling the even number method written within even number. So I'm giving the number 4. That is the number that's going to be verified. And system.assert equals. So this is the statement which the platform provides to verify or check if your unit test is providing you with the right kind of output. And if the method is, how do you really verify if a method or if a piece of code is doing what it is supposed to do? So this is where the method, the assert equals method comes in. It takes 3 basic parameters. The first parameter is what is the expected value. Okay, so in this case I know because there can only be 2 expected values, right? because my method is returning a Boolean value. So in this case, my expected value I know is true. My actual value is being stored in the where result object. So it is actually going to compare if the actual value and the expected value and the actual value are matching, right? If they match, your test will pass. If they do not, and if let's say there is a failure, you will see that this error message is displayed. So the third parameter, which is the error message, is displayed within your console. So let me just go back and show you. So if you see earlier, when I just ran this particular class and there was a failure, okay, if I open up the logs, taking a moment. If you see that the same error message that we have included over here, okay, is output to the, sorry about that, is output to the console, which means that you can have custom error messages included in this particular parameter. It enables troubleshooting, especially when you have a lot of unit tests and when you have a very complex org. It helps pinpoint the exact place where the test method is failing. Okay, you could also have it output some values to see what is the uh,
Hey, Jigger.
you can do all of that fancy stuff, but it is recommended that
Hey, hi Jigar. Jigar, we are
hi
losing your voice.
guys, can you hear me?
We are losing your voice.
Hello?
Your voice is breaking, Jigar.
Guys, can you hear me?
Yeah, now much better.
Hello?
Yeah, now we can hear you, Jigar.
Okay, is it audible now? Okay. So I'm not sure till what point were you all able to hear me, but I'll just quickly explain the assert statement that is written in the code. So the assert statement just helps you verify the actual and the expected result. The first parameter is what is the expected result. The second parameter in this method is the actual output that your test method returns. And the last but not the least, the error message. Okay. Now, in this particular case, so this assert equals is a statement which is provided by is a method which is provided by the platform. We don't really have to write any code for that. All we have to do is just use it as it is. There are multiple variants to this method. So if you want to really see what are the different types of assertions, so there is system.assert as well. So these are all the variations to this particular method. So there is an assert method, which is just a single Boolean condition. You can do assert not equals. You can even choose not to include the error message. So you can have variations for that. But basically they all do the same thing. Okay. So what I was trying to showcase to you guys over here was we ran the test code, right? And okay, let me just run this again just to make sure, emphasize on my point. So I can see that 11 lines are covered out of 8. So testing this. So I'm going to go over and comment. Okay, I'm going to comment the check negative number method because that is a negative use case, right? And even once I comment this and I save this and I rerun the test code again, okay, because my of the code. However, it is very important to understand, what are the negative. You should always be testing negative, and that is purely the reason why, you should always include comprehensive set of unit tests rather than just trying to get a code coverage. Okay, so the moment I save and make changes, it's going to change the code coverage. Now I'm going to run it again, and you'll see that you should get the same code coverage. You see that? So the percentage is the same. The number of lines covered are also the same in spite of me reducing one test method. So this is, so the point that I'm trying to showcase is that make sure your use are comprehensive. Okay. If you write, okay. Now we're going to talk about some important concepts. I'm going to switch over to my slide. Okay, I hope everybody is able to see the slide deck. So one of the most common things, this used to be a challenge a couple of releases ago. What used to happen was, so as the definition goes, a private variable or a private method is only accessible by the members of that specific class, right? Members, which means that methods of that specific class or within that specific class. But in this case, usually what happens is when you write real world test cases, you end up writing a lot of private variables which are your and those are the variables which have your actual which have values that determine if a particular method or piece of code is doing exactly as desired. So before this feature came into play, the easiest way out was just to convert or change this private to public, right? And you would be able to access, but that's not a good practice. So what happened was a couple of releases ago, this annotation was brought in, which is add test visible. Okay, now what happens is when you mark a private variable with add test visible annotation, okay, it helps view the values or access those values within a test class. So now with this particular class that I have EP5 demo 3, I'm going to access the value of isEven private variable, which is a private variable within my EP5 number verification service class. And I have another variable which is also a private variable, which is the isodd private. Okay, but that is not marked with the add test visible annotation. So we'll just see how it behaves, like what is the behavior in this case. So let me just run this class. Okay, so when I run this test class, okay, it will go and execute the logic based on what is written in a unit test. Okay, and it is going to output the value of the isEven private variable, which is the private variable within my EP5 number verification service, and it's going to output that to the log. So I'm going to open up the developer the console log. And if you see, I am able to access the value. So isEven private based on whatever the logic was. I believe it was a valid even number, so the expected output was true, right? So you see the value of that particular variable is now accessible here, and I can use that within my test classes. Okay, now if I try to do the same thing with the odd private variable, I've commented it right now. If let's just see what happens if I try to do it with another private variable which is not marked as isTest @isTest visible annotation. Okay, and I try to save. It's going to give me an error, and let's see what the error is. The error says the variable is not visible, which means that it is not accessible. So if I want to access this, I will have to make sure that I'm going to also demarcate it with the @isTest visible annotation. Once I do that, I make changes over here, and then I go back to my earlier class. Okay, and I try saving this now. It'll help save that particular statement piece of code. So now it is accessible. So this is how you can actually access private variables or variables which are very specific to another class within your test class. Okay. Another important concept that we need to understand from a test code perspective is to be able to understand the limits. Now, this is a very important piece and crucial to writing all your real world unit test cases. So usually what happens is, you don't really write unit tests the way I have written it with testing numbers. You will be dealing and playing around with S object records, right? Whether it's an account record, whether it's a lead, contact, opportunity, whatever it is based on your business logic, right? But an important concept is to make sure that whenever you write your test class, okay, you do not rely on the data which is available within your org. Okay, so your org could already have like 500 account records, but the idea is you should not rely on that. The reason being, if you're writing your unit test code on, let's say, a developer sandbox, okay, and you had those 500 records, when you eventually move this to production, there is no guarantee that those records will exist on the production org itself. That's why, and hence what will happen is your test classes will start failing because you are dependent on the data which is there in the org. Hence, it is recommended that you don't really write or rely on the org's test data, you create your own test data. But the problem with that is when you have a lot of complex use cases, okay, there are limitations on the total number of DML statements and the SOQL queries that you can eventually execute. And as a result, what happens? So you have DML statements and SOQL statements being executed in order to create your test data. Now you have your own test code and you are also using your DML statements and SOQL statements. Eventually, if you have too much of data and if it's a complex logic, you're going to hit your limits because Salesforce mandates that, or there is a governor limit set for every execution context that I can have at max. I believe it's the number is 100 for SOQL and 200 for DML statements. So I can only execute those many, especially because all the methods will execute in a single execution context. Okay, so how do I let me correct that. The code within a single method executes in a single execution context. So how do I make sure that my test data creation doesn't eat up into the actual governor limits, because my entire objective of writing a unit test is to be able to test effectively, right? So how do I make sure that I am able to test that without really being bothered of my governor limit constraints? So there are two statements or two methods that Salesforce or force.com platform gives us. One is the start test and the other is the stop test. Now, what I have done here is I have written some dummy code which will insert 10 accounts within my Salesforce instance, 10 account records to be precise. And then I'm also doing 10 SOQL queries. Okay, this is just to simulate the test data creation. Okay, and then I'm checking what are the limits after that execution happens. Then I introduce the start test and stop test and I'm trying to showcase what are the limits available now. So let's see what happens. Okay, and after the stop test completes and you're going back to the previous execution context, what are the limits available again? So I'm going to run this particular test, and because we have debug statements, we're going to go over to the logs and see it once we run the test code. So the most recent test code here, test code execution, appears below at the bottom. Okay, so there is only one method that we have, so that it executed fine. Let's go to the log and see the behavior in this case. So if I open up the log and I filter by the debug statements, if you really see that before the start test executed, 10 out of those limit of 150 was consumed and 10 out of 100 was consumed for SOQL statements, and for DML statement the limit is 150. So because we did 10 statements, or we did 10 inserts, it showcases that 10 statements were consumed. Same goes for the SOQL query. But what happens? Wait a minute. The start test and the stop test Now we are in between start test and stop test. And now if you check the limits, it shows that there is nothing which is consumed, which means that when you use a start test and a stop test within your test code, right, it gives you an additional set of governor limits, right, because of which you can have a fresh set of governor limits which can be completely utilized to core the logic or the test the logic of your functionality without really being bogged down by the overall governor limits enforced by the platform. Okay. And if you see again, you go back, once the stop test completes, okay, which is after stop test, you will get the same values, which means that it will keep the same record, which is 10 DML statements have been executed and 10 SOQL queries have been executed. So it is an important piece. This teaches us, or this really tells us, that we should be creating our test data, all the test data, before the start test methods. Okay, and only the actual core logic to test your code should be imbibed or included between the start test and stop test code blocks. Okay, moving on, there is another important concept that we need to we need to understand is about. So one is, we said that you can create your own test data, or you should be creating your own test data. And the only way to do that is by writing unit test code. Okay, so you end up writing your test code, you actually insert some records, and that is how you create the test data. But what if I don't really want to write any piece of code and still create my test data? The platform gives you the ability to do that as well. And that's where you can use the test.loadData method, right? So test.loadData method is an important piece which helps us understand, or which helps us load data from a CSV file. So how does this work? It's a standard method made available by the Force.com platform, and it accepts two parameters. First is, what is the type of object that you are loading? Okay, so whether it is an account, what is the S object type? Whether it's an account, contact, opportunity. And second is, this data, where does this data reside now? If you're not creating it, if you're not writing code for it, where does it reside? It resides within your static resource. Okay, and that static resource contains an actual CSV, right? So a CSV file is a comma separated values file. You include all the data, or all the records that you want to load, and you refer the static resource within this particular method. And the moment you run or execute your test class, the data will be loaded and it will show up within the variable that you're trying to hold the data. Okay, I'm moving through things quickly in the interest of time, because there are a couple of important concepts that I want to showcase. Impersonating users. Okay, one of the most important things that we need to do is on the Salesforce platform is to check only the right user has the right kind of access, or is able to use the feature that he is truly authorized to do. So how do you do that? Okay, you do that by making sure that you test or write your unit tests in the context of a user. And how are you going to do that? So we're going to be doing that with the system.runas statement. The system.runas is another statement where you can execute code in the context of a specific user. Now, how do we do that? See, one of the things you got to also understand is there are two things over here. When you create users or profiles on the Salesforce platform, there is a license that ties in with every user or every profile, right? So the moment you insert a user record, it will consume a license, right? So you don't want to do that. You want to make sure that your test code or your unit tests run independently, whether the licenses are available or not. Okay. Of course, the bare minimum licenses will be available, but let's say you're testing in the context of two different users, let's say a marketing user and a sales user, right? And that particular, you don't have so many licenses, but you want to test in conjunction with those personas. You don't really want to insert a user or really do an insert statement for that. Okay, because you're not sure that when this code moves over to production, you're going to have those licenses available or not. You could have a lesser number of licenses available, especially even from a SI standpoint or an ISV partner standpoint. When you're building products, you end up installing a product on any other customer's org, and you don't know what that org is going to be like. What is the number of licenses? So if you're really, so that is where this particular feature comes in handy. It helps you impersonate and exactly execute code in the context of that specific user. So what I've done over here is I've written a very simple unit test method. Okay, the method is, it is just instantiating, mind you that I'm just saying instantiating because I'm not really inserting the user over here, and I'm whatever user that who has been instantiated, I'm just running test code in the context of that. Okay, so before running this particular user, or before running as a specific user that I've created, the user context that is set is different from the one that is set when you do a system.run as. So let me just quickly execute this. Okay, so once I execute this particular piece of code, I'm going to again go to my console log, open it up, filter my debug statements. So now if I see, ignore the first line for a minute, I'll explain to you what it means. So if you see, before the run as, the user context that was being considered was a different user. Okay, the IDs are different. But after the run as statement, and when the debug statement within the run as block execute, they are giving me the context of the user which I created it, which is this sample user, right? So this exactly tells me that the user context which is set is for that specific user which is included in my run as. Okay, so this is how you can impersonate different user types. And again, a marketing user and maybe an admin and then maybe a business user. Okay, just so it is ideal to make sure that you are writing your unit test in conjunction with specific to each user persona. Okay, so that is what you can do with a run as. Last but not the least, there is something called as a see all data, and I said you can rely on the see all. You should not be relying on see all data. See all data is basically when you set see all data equal to true, it tells the platform that you are relying on the records that exist in the platform. Okay. So when I ran the test code, because this was already true, you see that accounts from these orgs, whatever exist on my org, have come up and they are available within my query. So I think that I put a limit 10. So the top 10 accounts just came in and I was able to access that. Now let me do the same thing. The only thing I'm going to do is I'm going to just change this to false, which means I'm going to tell the compiler that I'm not going to rely on the records which are available on your org. Okay. So now the output should be, when I run the test code now, I shouldn't be able to see the records and there should be no records that should be printed. Okay. So if you see now, there are no records printed, which means that I cannot have access to any of the records. As a best practice, make sure that it is always set to false unless you have a really valid reason of why you would want to set it to true and be dependent on the data that you have in your org. Okay, so these are some of the key aspects in becoming a pro. So these are some of the advanced concepts that I've explained for writing unit tests. Last but not the least, there are certain best practices which I would like to emphasize on. One of the first things is make sure that you test for use cases and not code coverage. Don't try to achieve the 75% mark. Make sure you're covering all your use cases, and in turn you will automatically achieve your 75% mark. Make sure you're testing all the use cases, not only just positive and negative. You're including assert statements, test data. Okay, you're creating your test data within your code, whether you're using the load data method to load it from a CSV, or you're writing your own code to build that out. But that's something which is extremely important, right? Try to create or always create test data before a start test method, because start test gives you a separate set of governor limits which can only be utilized to test the actual code. Last but not the least, it is always, as a best practice, it is always good to document the assumptions you have made while writing your unit test, because that helps you go a long way. Let's say 6 months down the line, if somebody else is looking at the same code, that person is able to understand, what are the assumptions that were made at that point in time to test the particular code. And if something has changed, and by then the assumptions, those assumptions, they just get to know whether those assumptions still hold true or not. And last but not the least, if you got a big chunk of test code, don't rely on the on testing your application in entirety by running all the test code at once. Instead, try to break them down into logical chunks. So maybe if you've got like 5 features, you can distribute your unit tests across those 5 features, making sure that each of those unit tests are doing what they're supposed to do and testing what they're supposed to do. Okay. Last but not the least, I want to show just one very important feature. I talked about using test code as a change management tool, right? And I just wanted to showcase that to you. So what I'm going to quickly do is, let's say everything is working fine. Okay, today you deploy everything to production and everything is fine. And now you introduce a change. You introduce a new validation, which is changing the original code. Okay. And you made the changes without really understanding or identifying what is the impact of this change. Okay, so now you have already test classes which are written in conjunction with this. Now let's see what happens to this. Earlier all of this was working and all of these test classes were working fine, right? Now when I run this particular test class, we will not get the desired result and our test classes will start failing. The same test class which we were executing earlier is now failing. So what does this show? This shows that test code is not only meant for testing or doing unit testing during development. If you are having changes in your business logic at a later point in time and you want to really make sure that those changes can be understand the impact and make a very controlled change, test classes can be used as a tool to effectively identify the impact and seamlessly introduce the change. Most of the times when the change is made, not a lot of thought process goes into what the impact is. So these unit tests help you write or help you identify those places of impact. Hence it is recommended that you write you cover all possible use cases. Okay, with that I come to the end of this session. There are some great resources which I've included in the slide deck and which will be included on our blog as well. Of course, nothing is complete without the amazing Prelude modules. So we have Apex testing and unit testing on the Lightning platform. So what we try to cover here is just the tip of the iceberg. I'm sure most of you want to get your hands dirty with this, and that's where this is very handy and is very useful, where you can actually write some test code yourself and become better at it. All right. With that, we come over to the question and answer session. Maria, do we have time left for question and answers? I know we've gone overboard.
Yeah, Jigar, like most of the question and answer, I already posted the answer for that. And only one thing, like somebody asked, can we execute the test class from the VS Code?
Okay, so yes, VS Code is VS extensions or VS Code extensions is another IDE. So if that's the question, yes, you can go ahead and execute unit tests from your VS Code as well. Is that the only question, or are there any other questions?
I already provided the answer of most of them. If somebody
right.
have any question, feel free to unmute yourself and ask the question directly to the Jigar. Big silent means everyone are good here.
Okay. If you don't really have any questions at this point in time, maybe. Um, and if you have a question, if you have questions at any later point in time, please just go ahead and post the questions on the blog, and we'll make sure that we answer all your queries. Thank you so much for joining in today's session. I know we did go a little bit overboard in terms of time, but I think that was essential in making sure that we understand each of these concepts. Thank you once again, and keep watching us, keep following us on the YouTube channel, on our Twitter handles, and if you have any comments, feedback, please, we'll be more than happy to hear from you. So thank you so much. I really appreciate all of you joining in today.
And thank you everyone for the joining, and thank you so much, Jigar, for the great session.
Yes, thank you.
Thank you.
Thank you.
All right, bye guys.
Bye.